The topic of these video lectures are device driver, terminal input output, modules of process management. Now first we start device driver. A device driver is a computer program that operates or controls a particular type of input output device that is attached to a computer. Drivers are hardware dependent and operating system specific. Input output device has its own characteristics. There are device drivers for for printers, display, CD-ROM readers, diskette drivers, and so on. A device driver uses buffers, flags, registers, control bits, and status bits for a particular device. Each different type of device has its own driver. The device driver was used from library. The next is terminal input output. A terminal or visual display unit, that is VDU, is input output medium. Terminal hardware can be divided into two parts. Number one, keyboard, which is used as an input medium, and second, video screen, which is used as output medium. Terminal can be dumb terminal or an intelligent terminal. Now, what is a dumb terminal? A terminal that depends on the host computer for its processing power is called as a dumb terminal or thin client that accepts data from CPU. Output devices such as monitor and keyboard are an example of dumb terminal because it has zero processing capabilities. Next is intelligent terminal. A terminal with built-in processing capability but no local disk or tape storage. It may use a general purpose CPU or may have specialized circuitry as a part of distributed intelligence system. Intelligent terminal can carry out some processing on the input. Intelligent terminal has more powerful hardware and software. Now terminals are classified as RS-232. Now hard copy and glass is an example of RS-232. Next classification is memory mapped. The memory mapped terminal has a video RAM. It has a terminal hardware. A alphanumeric screen can display 25 lines, each consisting of 80 characters, that is 25 into 80 equal to 2000 characters. The required video RAM size is 2000 bytes. All the 2000 characters are stored in video RAM are displayed on the screen by video controller. When entire data from keyboard, it is moved to video RAM as appropriate places, after which it is displayed. Now for example, alphanumeric characters oriented and graphics bit oriented is an example. Next is modules of process management. Process management is the process by which operating systems manage processes, threads, enable processes to share information, protect process resources, and allocate system resources to processes that request them in a safe manner. Now, what is process? A process is a program under execution which compacts for the CPU times and other resources. A program loaded into main memory for execution becomes a process. It contains multi-programming. Multi-programming can run two processes simultaneously. The number of processes running simultaneously and competing for the CPU is known as the degree of multi-programming. Consider if process 1 waits for on input output, CPU execute process 2 and vice versa. That is, CPU process some process to execute. In such a case, time lost is turning attention from process 1 to process 2. It is called as a context switching, and this example this example shows a context switching. Now, next is what is a context switching? The process of saving the context of one process and loading the context of other process is known as the context switching. In simple term, it is like loading and unloading of the process from running state to ready state. In context switching, the memory contents of old process are stored somewhere, otherwise restarting this process would be impossible. The status of CPU registers and pointers to memory are stored in specific memory area called register save area, and then CPU starts executing another process. Both the processes are in main memory even after context switch. After some time, the old process is scheduled again and CPU executes it from where it had left from. The time is lost in context switching is very low. Next is a process state. Operating system defines three basic process state is as. The first is running. This state CPU can execute only one process at any time at any given moment. This is running process. Now second state is ready. In this state, a process which is not waiting for any external event such as input output operation and which is not running is in a ready state. Next is blocked. When process is waiting for an external event such as input output operation, the process is in blocked state. Suspended ready. When the ready queue becomes full, some processes are moved to suspend ready state. And suspended block, this state when the waiting queue becomes a full, and this figure shows a process state. Now next is process scheduling. The process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and the selection of another process on the basis of a particular strategy. Process scheduling is an external part of the multi-programming operating systems. Objectives of process scheduling are listed. Number one, fairness. It refers being fair to every user in terms of CPU time. Second is good throughput. Refers to the total productive work done by all the users put together. Third one is good CPU utilization. Is the fraction of the time that the CPU is busy. Next is low turnaround time. Is the elapsed time between time as a program or job is submitted and the time when it is completed. Next is low waiting time. Is the time a job suspends waiting in the queue of the newly admitted processes for the operating system to allocate resources to it before commencing its execution. And the last is good response time. Is the time to respond with an answer or result to a question or an event. It depends on degree of multi-programming efficiency of hardware and policy of operating system to allocate resources. The response time is extremely important for online or real-time system. The next is a priority. Priority is a method of scheduling processes based on priority. In this method, the scheduler chooses the tasks to work as per priority, which is different from other types of scheduling. The priority can be global, that is external, or local, that is internal. The external priority is specified by user externally at the time of initiating a process. During execution, it can be changed if the user does not specify priority, then default priority is assigned. The internal priority is based on the calculation of current state of process. In this priority, firing a process can be forced to specify the expected time that the process is likely to take for completion. The operating system can set internal priority which is highest for shortest job. The next is multitasking. Multitasking is a concept of performing multiple tasks, also known as processes, over a certain period of time by executing them concurrently. Multitasking always programs flexibility and improves CPU utilization. Consider a process consisting of two tasks. Task first is 0, read a record, processor records, task 0 and end. Then second task is write a record and task 1 is end. In the above task, if the task 0 is blocked, instead of blocking entire process, the operating system will find out whether the task is 1 can be scheduled. When both the tasks are blocked, only then the entire process is blocked. Again, if one task is ready, the process can be moved to ready list and then scheduled. The next is time sharing. Time sharing is a technique which enables many people located at various terminals to use a particular computer system at the same time. Time sharing or multitasking is a logical extension of multiprogramming. Processor's time, which is shared among multiple users simultaneously, is termed as a time sharing. For example, the operating system meet daily access to a certain variable by certain processes.